Now in 4.2, we also talk about quadratic functions. So in the guided notes, they kind of go over the form of them, moving them around, the vertex. I'm also going to talk a little bit about that, not terribly in depth. But a quadratic function is a function of the form, well, a quadratic equation was that ax squared plus bx plus c. Function's the same. It's the exact same thing. F of x is ax squared plus bx plus c. I need this extra condition that a isn't 0. And the reason I need that is if I don't have it, if a were 0, then I'd have no x squared term, and then I'm back to something linear, not quadratic at all. So the shape is called a parabola. And when I was doing the 4.1 stuff, which is yesterday for me, I don't know, you might be watching all of these on the same day. But when I was doing the function stuff, graphs yesterday, I actually kind of talked about the parabola. Okay, the most basic quadratic you could have is where there was no b or c and a was just 1. So if you have that, here's your x squared. This is what they look like, basically. Now, you know that x squared, or squaring something, gets rid of negatives. So both 1 and -1 are the same thing. 2 and -2 are the same thing, right? So there's this symmetry, and they both go down to 0. So this point, when x is negative, for x squared, when x is negative, I get something positive. When x is positive, I still get something positive, and I have 0. This point where it flips from going down to going up, or it flips from the thing that I'm squaring being negative to the thing I'm squaring being positive, that is called the vertex. Now, in the guided notes, and I have some issues with the way they do this, in the guided notes, they give you the vertex form. Honestly, this should be covered in a later section, because all the stuff where it's saying a horizontal shift and a vertical shift and blah, 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 we haven't talked about any of that. We've not done that in any context. We're going to do it in section 4.4, but we haven't done it yet. 4.4, it's in section 4.4. So we're going to talk about these, what are called transformations, in a couple sections. For now, I want you to just know vertex form. Don't worry about like why it is and all that stuff. So the shape is called the parabola. And how do they define vertex? They say, where the graph changes direction. So the point where the graph changes direction is the vertex. Okay, so the vertex form is that a x minus h quantity squared stuff. So for g of x, a x minus h quantity squared plus k, this has a vertex of HK and opens up if A is positive and down if A is negative. All right, so this is what we're going to need in order to graph parabolas. I'm not really so much concerned about the stretch, compress, opening skinnier or broader. It doesn't really matter. I'm most interested in, does it open up or down, and where's the vertex at? Okay, so let's look at a few problems where we graph, because I think they make you graph them on hawks. So graph, find the vertex, that sort of thing. All right. So find the vertex of the following parabolas. List any x-intercepts, graph the function. Now in 4.4 we're going to talk about different ways to graph these. For now, you just need to be able to, like, I think they ask you to pick 2 other points that are on the graph. So I'm actually going to pull up one of their problems. Have one ready here. Okay. And I'm going to do a couple of them with you. So this h of x is x minus 5 quantity squared minus 4. Okay, so I put 3 little pieces of information here. These are some things that can help us graph. First, how does it open? So this thing does not have a negative here. You could imagine that there's a understood 1. 1 is positive, so this thing opens up, right? So it looks like a U. The vertex is HK. So I'm actually going to write a x minus h quantity squared plus k. So I need h and k. So I have x minus 5 plus, or sorry, minus 4. So what is h? H is that 5. What is k? Well, on my form it's plus k. Here I'm subtracting, so I must be adding negative 4. So the vertex is 5, negative 4. For the x-intercept, okay, actually before I even go to graph, or sorry, look for x-intercepts, let's look at a graph. So this is A. It's 5, negative 4. So 1, 2, 3, 4. Sorry, that's negative 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. So right here. And this opens up, right? So it is going to cross the x-axis at some point, which means it does have x-intercepts. All right. Now remember, an x-intercept is when your y value is 0. Okay, and not only is it going to have, not only is it going to have an x-intercept, but it should have two of them. So x-intercept, that means y equals 0. Okay. Y, or h of x, so that's x minus 5 quantity squared minus 4. So this is a quadratic. You can solve this however you want. This was back in chapter 2. So one way you could solve this is the square root technique, where you end up taking a square root of both sides. That's probably what I would do on this one. It's okay if you multiply this out. Okay, so I get x minus 5 quantity squared equals 4. Take a square root of both sides. 4, square root of 4 is plus or minus 2. X minus 5, so either x minus 5 is 2 or x minus 5 is negative 2, which means I get, let's see, 7 and 3. So my x-intercepts are 7, 0 and 3, 0. Okay. Now that I have that, I can go back to my picture. 7, 0 and 3, 0. And these were equally far from the vertex, right? So I've got this line of what we call line of symmetry. I had to move 2 to the right and 2 to the left, and that got me my x-intercepts. Okay. Now, it's not always that you just move 2 to either side, and that gives you your intercept location. Okay. So let's try another one of this type. Oh, wait, I want to show you doing it on hawks. That's right. So let's move. Let's get this visible. There we go. Okay. So find the vertex. We did that. It was 5, negative 4. How many x-intercepts? It has 2 of them. They were 3, 0, and 7, 0. Okay, so find 2 points other than the vertex and the x-intercepts. How to do this? So what I would do is the easiest thing to do, or an easy thing to do. You could just pick any value of x that you want and plug it in, right? Any value of x that you want. If I chose x equals 0, I can do that. To find 2 other points, so for hawks, so x equals 0 is usually pretty easy. If 0, then I get that y is 0 minus 5 squared minus 4. Sorry, I forgot I had the screen on top of my paper. So to find two other points, choose any value of x you want. So x equals 0, that would mean y equals 0 minus 5 squared minus 4, which is negative 5 squared minus 4, which is 25 minus 4, which is 21. So one of my points would be 0, 21. Another one you could do, I don't know, say x equals 1. Actually, let's not do 1. Let's do x equals 6. It really doesn't matter what points you choose. So x equals 6, that means y is 6 minus 5 squared minus 4 is 1 squared minus 4, which is 1 minus 4 equals negative 3. Okay, so remember that the points are in, out, right? So in went 0, out came 21. In went 6, out came negative 3. All right? So when I go to type that into Hawks, 0, 21, 6, negative 3. Good. Now if you look at our graph, so I didn't show you guys when I was typing because I keep forgetting to switch it, but we typed those in and it worked out no problem. Now if I go to my graph, now this graph is not perfect, but I moved up 2, or sorry, I moved up 4 when I moved 2 away. So if I move 1 away, I would move up 1. So 2 squared gives me 4. So if I move 2 in the horizontal direction and in the vertical direction, I end up with 4 because 2 squared is 4. If I move 1 in the horizontal direction, I'm going to move 1 in the vertical direction because 1 squared is 1. So here's my 6, negative 3. So I could have also done 4, negative 3. That would have worked. Plugging in x equals 0 is pretty simple. You can always pick, like if you sketch your graph, you can always pick like a point on either side of the vertex as well. Okay, so I'm going to put this back up. Okay, points can be dragged or you can move them using the arrow keys. Okay, so move our vertex. It was 5, negative 4. Okay, and then we had, is there a way to zoom in? Oh no, it's just my angling is making it hard to see. Okay. Okay. Here we go. Sorry, I had to bend my head weird. My screen, some of the lines are showing up and some of them weren't. Okay, so there's my picture. Done. Okay. So if you are, so this next one that I have pulled up is the exact same thing. You know, find your h and k, find your intercepts. What might be a little bit harder is if it's in this form. So let's look at a problem that's in that form. So x squared plus 9x plus 20. X squared plus 9x plus 20. So this is still 4, 2. All right, now on this one, you're not in the right form, right? So we need vertex form first. All right, so to get it into vertex form, we're going to be using completing the square. So I said back when we first learned completing the square that I don't think completing the square is that useful for solving equations, but we need it for this vertex stuff. So Q is x squared plus 9x plus 20. We are completing the square in x only. So I need b, half b, and half b squared. Oh dear, the b is odd. That's okay. So b is 9 over 2. Sorry, b is 9. Half of b is 9 over 2. Half of b squared is 81 over 4. So 9 squared over 2 squared. All right, so what is important about this is before, whenever we did completing the square, we added to both sides, right? I can't add 81 over 4 to both sides now. Because if I add to the left-hand side, I'm not doing q anymore. I'm doing q plus 81 fourths. It's not the same thing. I have to add and subtract. If I add and subtract, then I haven't changed the problem. So I have added 0 into my problem, but it's a strange looking 0. It's 81 fourths minus 81 fourths. That equals 0. So then I'm going to complete the square. I did complete the square, and I'm going to do my factoring. So q of x, remember it always factors as x plus half b. So x plus 9 over 2. And if you do your common denominator here, you have negative 1/4. So I leave you, that getting that negative 1/4 to you. So this is negative 1/4. This is your vertex form. Now you can answer the questions about how it opens, what the vertex is, what the x-intercepts are. Okay. So this opens up because A is 1. So it's positive, so it's going to open up. The vertex is HK. Here, remember the form is a minus h. So if I'm adding something, that must mean I'm subtracting a negative. So my vertex is negative 9 halves, comma, negative 1/4. My x-intercepts, I'm going to set the function to 0. So 0 equals x plus 9 over 2 quantity squared minus 1/4. Now this vertex is down in the third quadrant. So third quadrant opens down here. So it is going to have to cross the axis again, so it does have x-intercepts. Okay. So solve this, add 1/4 to each side. Take a square root of both sides. So add 1/4. I get 1/4 is x plus 9/2 quantity squared. Then I take a square root of each side. Square root of 1/4 is a half. And I have two linear equations. One of them says that x plus 9/2 is 1/2. The other says that x plus 9/2 is negative a half. So 1 minus 9 is negative 8. Negative 1 minus 9 is negative 10. And I have negative 4, negative 5. All right, so my two x-intercepts would be negative 4, 0, and negative 5, 0. Okay, so in Hawks, they ask for the vertex first. So the vertex is negative 9/2, comma, negative 1/4. So that was right. How many x-intercepts does it have? It has 2. They're negative 4, 0, and negative 5, 0. Oops. 0. Cool. And find 2 points on the graph other than the vertex and intercepts, and then it's going to plot it for you. So they're not making you plot the vertex that has fractional coordinates. So what would I do? Do x equals 0. That's nice and easy. And it's extra easy because zero plus 0 plus 20. That's nice and easy. So in goes 0, out comes 20. In goes 0, out comes 20. For another point, 1. 1 plus 9 plus 20 is 30. So in goes 1, out comes 30. So, 1 comma 30. Okay, so if I look at this graph, the vertex is negative 9/2, negative 1/4. So 9/2 is 4.5. So it looks like it's at the right spot. It's very close. It's in the right quadrant, so it should be good to go. Dun da da.